Hello, and welcome to Chapter 1. Introduction to Big Data. So what is Big Data? As we all already know, data is everywhere. We generate and use data every time we use our smartphones, computers, voice assistant, various entertainment devices and home appliances. Nowadays, even devices like refrigerator or washing machine can generate some data and text their owners when they finish the task. But the list goes on. There are numerous IoT devices, industrial sensors, surveillance cameras, medical devices and so on. We also generate data through our interactions with the world around us. For example, when we shop, we exchange credit card details, possibly billing and shipping addresses. When we travel and socialize, we take photos or videos and share them with friends and family over various messaging applications or post them on social media, and so on. The amount of data that we generate every day is growing at an exponential rate. This is due to a number of factors, including the increasing popularity of the internet and the rise of social networks, and of course, the development of new technologies and devices we just mentioned. This massive amount of data and its means of successful storage and processing are often referred to as big data. Big data is not a specific data set or technology, but rather a unifying concept that describes the challenges and opportunities arising from the storage and processing of huge databases. It refers to data that is so large and so complex that traditional data storage, analysis methods and processing tools simply cannot cope with it. So, Excel is a fantastic and very powerful tool, but we won't be processing big data with it. Although it can be used very well in some cases and for smaller data sets. Big data can also be understood as a methodology, or a set of methods and best practices that are used for storing large data sets in structured, unstructured and semi-structured form, using various application solutions and tools, and processing them into a structured format for the purposes of analytics and creation of predictive models, or for the purpose of discovering correlations, trends and insights that are not visible with small data sets. It is often characterized by 3V concepts, which refers to a large and complex data sets that are collected at high speed, in high volume and in various formats. So, we have volume. Even though there is no exactly defined size which says that some database is considered as big data, usually big data sets are very large, containing billions or even trillions of records. Here we also have CRUD operations, which is an acronym for create, read, update, and delete operations. These are the operations that can be performed on the databases, and here is important that no matter how big database is, operations on data must execute efficiently and without lags or glitches. Velocity means that big data sets are generated and collected at very high speeds or in real time. So this represents the speed at which data is being stored in the system. Lately, social networks are generating large amounts of data in relatively short time. Variety refers to the fact that big data sets are usually collected from a variety of different sources, and they can be of different types, such as numbers and text, images and videos, and of different formats, including structured, unstructured or semi-structured format. Structured data is data that is organized in a predefined format, such as a relational database where data is written in tables in form of rows and columns, or data in Excel or CRM, or any system where data is neatly organized. Such data is typically easily accessible, and easy to search, analyze and manage by using traditional data processing tools. On the other hand, unstructured data does not have a specific structure or data type. It is not organized and does not adhere to any predefined format. This type of data can encompass various forms, including text, images, multimedia or other file formats, as well as any combinations of the well-known and unknown formats. Examples include social media posts that can contain text, images, graphics, animations, audio or video, or emails which bodies or attachments comprising various data types and formats. Due to its lack of predefined structure and diverse sources, collecting, analyzing and processing unstructured data can be challenging using traditional data processing tools. Semi-structured data is a combination of both, structured and unstructured. This is the data that has some structure but not as rigidly as in structured data. Some examples are data log files from different devices, configuration files, sensor data, and files like CSV, XML or JSON. It can be easier to search and analyze it than unstructured, but it is still more challenging to process it than structured data, using traditional data processing tools. Usually you need to have some kind of specific application that understand and know how to work with these data types. Some organizations go even further, and add some more V concepts into the classification, like value, veracity, visualization, and virality. Value is important because not all big data is valuable. Some data may be irrelevant or redundant. It is important to identify the big data that is most valuable for decision making and focus on analyzing that data. Veracity, because big data can come from a variety of sources, and not all sources are equally reliable. It is important to assess the veracity of big data before using it for critical decision making. Visualization is important because big data can be complex and difficult to understand. Visualization tools can help to make big data more understandable and accessible to decision makers. Virality refers to the rate at which data is shared and spread. It can have a significant impact on the value and usefulness of data. While the size in big data is not precisely defined, and also the possibility of storage and processing data is different for each organization and is constantly changing, we can say that these datasets are often measured in terabytes, petabytes, or even zettabytes in size. To put this into perspective, today's average smartphone has storage of around 200 gigabytes. 1 terabyte equals 1000 gigabytes, and 1 petabyte equals 1000 terabytes. Additionally, 1 zettabyte equals 1 billion terabytes. The last one shows how large databases in big data can get. According to the World Economic Forum, the global datasphere, or the total amount of digital data available on the internet, was expected to reach 175 zettabytes by the year 2025. For instance, Google's GFS, or Global File System, a large database that stores search indexes and data from Google's services such as YouTube, Gmail, and Drive, has already surpassed 100 zettabytes on its own. When we consider other large datasets like Microsoft's Azure Blob Storage or AWS Amazon Web and Cloud Services, and many other that are available today, we have already greatly exceeded the projected number. So why big data? In summary, the potential of big data lies in its ability to provide deeper insights and competitive advantages. Big data enables the identification of patterns and trends that would be challenging or impossible to discover in smaller datasets. This information can then inform better decision-making across various sectors, including business, government, healthcare, and beyond. Also, it can be used for improved efficiency and optimization of business processes through identification of bottlenecks. Once bottlenecks are identified, tailored solutions can be developed to address them, streamlining operations and enhancing overall performance. For example, Amazon utilizes big data to analyze customer purchases and identify new trends. This information is then leveraged to optimize its supply chain and enhance product recommendations. Another example is United Airlines, which uses big data to analyze flight data and identify operational bottlenecks. This information is then utilized to improve flight schedule, reduce delays, and optimize fuel consumption. Big data can also be used for innovation, to identify new trends and opportunities which can be used to develop new products and services. For example, Netflix uses big data to analyze their customer information and identify the types of content that is most popular to users, regarding the parameters like their age, gender, or their region. This information is then used to develop new content and recommend other content to the users. Or for example, a retail company might use big data to identify customer segments, products, or services that are likely to be popular in the future. A manufacturing company might use big data to identify product defects or to identify features that clients are most interested in. Some of the possible examples of application are: in automotive industry, for development of autonomous driving systems and systems that analyze data from sensor logs, cameras, and other devices, to identify objects and obstacles in the road. In GPS technology, to improve the accuracy of GPS navigation by analyzing data from multiple sources, such as satellites, cell towers, and ground-based stations, which can be used to improve the efficiency of traffic management and to predict traffic congestion. Also in healthcare, to improve diagnoses by analyzing data from medical records, imaging scans, and other sources, or to develop new treatments and drugs and to track the effectiveness of these treatments. Or in cybersecurity, it can be used for protection of computer networks and digital resources from cyber threats, by analyzing data from network traffic, emails, and other sources, or to develop new security tools and techniques. These are just a few examples of many ways that big data can be used to improve technology, and thus quality of lives. And this concludes our Chapter 1, on Big Data. Please proceed to Chapter 2.